Yeah, good morning my dear students. Today I am going to discuss about the principle behind electrophoresis. What is electrophoresis? Basically electrophoresis, before going to discuss about electrophoresis, we should remember that the velocity of the molecule is having two factors, is affected by two factors. One is driving the motion and the other one is resisting the motion. Suppose if you want to run a car, we need accelerator and the brake. Similar manner, we need the driving the motion as well as resisting the motion. So the driving the motion is given by the driving force, which is given by the formula Q into X. Q is the charge of the molecule expressed in coulombs and X is the electric field strength expressed in volts per meter. Right? So this is the force by the electric field. Driving the motion is given by force by the electric field, that is given by the value Qx. Now when we talk about the resisting the motion, if you want to make a brake, right? So resisting the motion is given by the frictional force. One is the forward force, another one is the backward force. So the backward force is also called the frictional force, which is given by the terminology Fv. What is called F? F is called frictional resistance or frictional coefficient, and V is the velocity of the particle. So this is the two important things, and whenever you want to have a steady state velocity to balance the things, then both these equations should be equalized. So particularly for the larger molecules, asymmetric molecules encounter more frictional resistance. When you go for the larger molecules, definitely you have more that resistance, frictional resistance will be present. So when electric field is turned on, whenever electric field is turned on, the molecule quickly accelerates to a velocity at which these forces balances and moves steadily at this rate. So a steady velocity is determined by the balance of both the forward force and the backward force. So we can say that Qx is equal to Fv, or simply we can say V by X is equal to Q by F. What is V? V is the velocity and X is the electric field strength. Right? So that is nothing but the rate of motion per unit of electric field strength. Rate of motion is nothing but velocity. Velocity by electric field strength is also called as electrophoretic mobility, which is given by the terminology mu. Okay. So, but if you look at the Stokes law for spherical molecule of radius r moving through a medium of viscosity eta, the Stokes law states that F is equal to 6 pi eta r. F is the frictional force, that backward force F is equal to 6 pi eta into r. So what we are doing, this is equation number 4 we are taking, use this F value in this equation. So what will happen? Qx is equal to 6 pi eta r into V. Right? So what will happen further when you use this thing, the electrophoretic mobility of the molecule. What is electrophoretic mobility of the molecule? Velocity divided by electric field strength. So that is nothing but V divided by X is equal to, so X we are bringing it here. So automatically what will happen? Q divided by 6 pi eta r. This is the final formula. This also new bar is called electrophoretic mobility. Either we call them as mu or we call them as V bar. So electrophoretic mobility of the molecule is equal to Q divided by 6 pi eta r. So electrophoretic mobility is directly proportional to the charge on the molecule and inversely proportional to the viscosity of the medium as well as the size and shape of the molecule, which is designed by radius. Right? So this is all about the various things you should remember, the factors affecting the molecules as such. Right? One is the mobility of the molecule depends upon the viscosity of the medium, the size, shape and the charge on the molecule Q. Right? There are some other factors also affecting the electrophoretic mobility. One is the ionizable groups present on the surface of the particle, and the second important parameter is sign and magnitude of the charge carried by the ionizing group. What is the sign and what is the magnitude, which is given by the ionic strength and the pH of the medium. These are the two important factors. The size and the magnitude of the charge is governed by two important factors. One is the ionic strength as well as the pH of the medium. Right? So what is called electrophoresis? Now if we discuss about what is the definition of electrophoresis. Electrophoresis, right? Electrical field we are going to separate. By applying the electrical field we are going to separate the molecule. That is called electrophoresis. So when an electric field is applied to a solution, right? A solute molecules with a net positive charge migrate towards the cathode and vice versa. This technique is called electrophoresis. Right? Whenever you apply an electric field to a solution, the solute molecules will try to travel, right? So whichever solute molecules are having the net positive charge, they will move towards the opposite terminal, that is cathode, and whichever molecules are having the net negative charge, they will travel towards the anode. So this technique is called electrophoresis. So charged molecules are getting separated under the influence of electric field is called electrophoresis. Now, the other important thing we are going to discuss in today's lecture is paper electrophoresis, right? So, paper electrophoresis, basically the electrophoresis we can do under two terminologies. If you want to use the state, based upon the state, there are two types of electrophoresis. One is called solution electrophoresis and the other one is called supporting electrophoresis. So, solution electrophoresis, example is capillary electrophoresis, and supporting electrophoresis, we are keeping some supporting material. It may be a paper or it may be a gel or anything, right? So, gel electrophoresis and paper electrophoresis coming under the later category, supporting electrophoresis, whereas solution electrophoresis, the classical example is capillary electrophoresis. Now, when we discuss about the paper electrophoresis, you can able to see here the diagram. So, it is very interesting. We have two terminals here. One is at anode having the positive terminal and the cathode is having a negative terminal. And here we are keeping the buffer solution because the sample has to be moving, right, in two different directions. Charged molecules in different influence of electric field, it is moving in two different directions. So we must, for movement, we need the buffer solution. So that is a mobile phase as such, the buffer solution, electrode vessel containing the buffer solution. And here the sample component mixture, we are applying it in the center of the paper. And this is the supporting medium here. So there are different types, horizontal paper electrophoresis, vertical type, different types of category are there, right? Horizontal paper electrophoresis chamber and vertical paper electrophoresis chamber are available. So here, if you look at here, we are just keeping the paper as a supporting medium, right? Supporting medium is paper. Then here we are keeping the spot. The spot is a mixture. So upon the movement, when you switch on the electric current on, so what will happen? The sample component will be getting separated in two different directions, right? So we are applying the spot mixture in the center. So what will happen? If the migrating component will be negative charged molecule, they will travel towards the anode. And if the migrating component are positive charged, they will travel towards the cathode. So this is how the components are getting separated. Now, paper is the supporting material, as you know very well, which is used for separating the mixtures of charged molecules. Particularly the small charged molecules can be separated by paper electrophoresis. So here a piece of filter paper which is wetted with buffer solution. Buffer solution is a very important mobile phase. So filter paper means we are using Wattman 3 mm filter paper we are using, which is wetted with buffer solution to control the pH and stretched between two electrode vessels. And the paper has been stretched between two electrode vessels, right? A drop of mixture to be analyzed is placed on the center of the paper. And the electric current is turned on. What is the electric current strength we are using? Basically, we are using 3 to 8 volts per centimeter in the paper, right? So this is the electric field strength of 5 to 8 volts per centimeter. Optimum we are using 5 to 8 volts per centimeter, right? After the molecules migrated for several hours, right? Once you turn the electric current on, the molecules will be getting migrated for several hours. The paper is removed. You remove the paper, dry it out and then stained with a dye that colors the substance to be examined. You can also stain it with dye solution, right? The spots can be identified by comparison with a set of standards run on the same paper. This is also possible. If you are running with the set of standards, that also we can compare the spots easily, right? Suppose if the unknown substance is radioactive, imagine that the unknown substance is radioactive. In that case, the spots can be cut out and the radioactivity can be measured by scintillation counting or Jaeger-Muller counter. So what is an advantage of this paper electrophoresis? The filter paper is cheap and very easy to use, right? This is the major advantage. But the disadvantage, many disadvantages are there. Some mixing occurs between the zones due to adsorption of molecules on the cellulose, because the paper, Wattman paper contains cellulose, right? So definitely some mixing occurs between zones due to adsorption of molecules on the cellulose material. And it is a slow method and a poor quantification. It takes lot of time interval, at least minimum 2 to 3 hours for running the paper electrophoresis, right? So therefore slow method and poor quantification. Also it requires the large sample for analysis. So these are all the demerits of paper electrophoresis. Thank you my dear students. Thank you very much.